All right, so we're gonna get started in a few minutes as we let some last people in, and yeah, some last people come in, and some more people come in who are coming in a little bit late. We'll start in around 12:04. I guess we'll start then. 12:03, 12:04. All right. Yeah, just we're just as I said before, we're just gonna wait for maybe 1 or 2 more minutes, and then we'll get started. As just in case some people are coming in a little bit late, and obviously we're gonna be sharing the recordings and the slideshows as well as we go on. All right, we're going to get started. So today, what we're going to be going over is some of the basics and some of the really interesting things you can do with Unix, which is one of the Linux programming languages, and it's basically stuff you can do with text manipulation. Because often when you're dealing with stuff on the command line in Unix, you're not going to be able to just open up a file on a text editor and say, oh, I can just change these lines and then that'll be it. You can't just. A lot of the times, either you don't have access to a text editor, or you have files that are thousands and thousands and thousands of lines long, and you realize that text editors aren't really that effective when you have that many things. Trying to change all that on the command line can be really, really hard without the right tools. But thankfully, Unix has a lot of those tools built in and stuff you can get that let you do really, really cool things with text manipulation. So, oh, and also there's going to be a sort of a practice thing you can do with this as well that I'm going to be sharing in a few days. That'll let you work through some of these commands and actually try these out in an actual like Unix environment rather than just trying to see like what they do on like PowerPoint. Okay, so what we're going to go over today is this is basically just like what we're going to be going over today. So today we're going to be going over um, redirection and pipe operators, regular expressions, character manipulation commands, line manipulation commands, and text manipulation commands, and like a couple of like general use Unix commands as well. So there's a lot of stuff we're going to be able to cover today. But also before I get started, like with a lot of these Linux things, like just reading about them, you can learn what the commands do. But the best way to actually like get familiar with them is to just try them out. Like the more you use these commands, the more you get familiar with them, the more you realize like what different like sub commands or what different things you need to use for your use cases. And the more you just play around with it, the better you're going to get with it, and the more you can actually learn about how to use these commands in a much more efficient ways or much more like complicated ways that like really like are fine tuned to like what you need to do. So the first thing we're going to talk about is what's called redirection operators. So the basics of redirection operators, or these are some of the basic redirect operators, is how to like redirect the standard, like the output, the input, and the error to files in Linux. So the basic redirection operators are like the greater than sign lets you redirect to standard output. The greater than and lets you redirect to standard output and standard error. The less than sign lets you redirect standard input. And these are like for redirecting it to files. Then you can append standard output, standard error, and redirect standard error. So what we mean by standard output, input, and error is like in Unix, when like you type a command and let's say there's an error with that command, then that error is called standard error. Or if you input something into like a Unix command, that's called standard input, and what that command returns back is called standard output. So output is what shows up on the screen, input's what you put in, and error is just the errors that show up. And so if you want to do redirection with input, what you can do with it is the standard redirection operator for input is the greater than sign, and it replaces the standard input of a command by the file that follows it. So it's not used much, as most of the Unix commands allow you to put file names as arguments. But let's say you wanted to cat one file. And cat is basically like a Unix command. Like there's a lot of like basic Unix commands that can help with like how to actually do these. But cat is a basic Unix command just to like show output, like output a file and show what's in it. So let's say you want to cat a file. You could just do cat my file, and that's allowed because cat takes in the file input. But if you wanted to use redirection, what you can do is cat and then put the redirection operator, and that means it'll take my input file as the input for the cat command. So you can do cat, the less than sign in my input file, and it's the same as doing cat my file. So it'll just output that file. Then there's also redirection for output. So there are two redirection output operators. The basic one is just a greater than sign, and it basically creates a new file if it doesn't exist, or overwrites an existing file if you give an existing file's name. So let's say you want to do ls minus al to my output file. So what ls minus al does is it lists all the files in your directory and lists like the permissions with them as well. So if you want to, hold on 1 second. Okay. If you want to like take that listing of all the files in your directory and put it into like an output text file, let's say you want to make a list of all the files in your documents folder on your computer, then you can do ls minus al, and that'll list all the files in your documents folder, all the hidden files and all the permissions on them, and it'll put all of that output, instead of putting it out into the command prompt, it'll put it into the output file. You can do output.txt. But then there's also the output append operator. And what it does is, instead of just writing or overwriting an existing file, it'll append it to the end of that file instead of replacing the file's contents. So let's say you want to make a list of all the different folders, not just documents. You want to do downloads, documents, your home folder, your users folder. So then instead of like rewriting every single time you do ls minus al, you can do ls minus al and then the append operator and just add it on to that same file over and over and over again as you go through all your directories. And then the last one is the redirection for error. So if you want to redirect error messages, then it's the to and then greater than symbol is used to redirect error messages. So let's say you want to do cat file name and output that error to log.txt. So if there's, let's say you mess up typing the file name, like file name 1, instead of doing file name 1, you do file name, and you forget the 1, then that error that comes up on the standard output where it says like, oh, file name does not exist, instead of putting that out, it'll put that into log.txt. So you can have like an error log of like, oh, what went wrong with this command? What went wrong with that command? Just keep adding on to that. Another really important thing with a lot of Unix commands, a lot of the commands that we're going to be doing coming up, is what's called the pipe symbol. So the pipe symbol is, that's the pipe symbol. It's kind of near the backslash on your keyboard. And what it does is it creates a sort of channel from one command to another. So the way you can think about it is kind of like a pipe with water. So whatever you put before it gets piped into what comes after it. That's the best way I can sort of think about it. So you can pipe commands into other commands, pipe commands into outputs. You can do a lot of things with this command. And it basically connects the output of the command on the left to the input on the command on the right. So it can be used to like link different commands together to perform like a really complicated task. Or you can put the output of one program into the input of another and put it into like a file or anything if you want to as well. So let's say, so these are some sort of like examples of how you could use pipes in some like pretty complicated ways. So let's say you wanted the unique name of a user who logged onto your Unix currently. So what you can do is you can run the who command. What who basically does, it tells you the names of like the users that logged onto Unix. And then you can pipe the users, like the list of users, into awk print1, which we'll talk about awk at the end. So if you don't know what this means yet, don't worry about it. We're going to be talking about this later. We're going to talk actually about a lot of these later. So if you don't understand what like sort or unique or awk does, we're going to talk about it later, so don't worry about that. But basically, if you get a list of users who've logged in, then you can do awk print1, so that list of users, and just get the usernames, because the who would print the usernames and a bunch of other things as well. You can sort them, and then you can get the unique from that sorted list. You can get a sorted list of names that only have unique names. There's no duplicates in them. Or you could check the status of some process. So ps minus ef is kind of like Task Manager if you guys have a Windows computer. Like if you guys have ever seen like Task Manager on like a Chromebook or on your computer, then you can think of it like that, where it shows all the processes that are running. So that's what ps minus ef does. It just shows the processes that are running along with some information about them. You can grep like, oh, I want to see, is Java running at this time, or is SQL running at this time? So you can get the output of all the processes, basically get like a listed form of like what's going on in your like Task Manager, and then grep, which is search that for whatever process name that you want. And a much more simpler example is, let's say you have a file like schoolnames.txt. It's a text file that has like a list of the names of everyone in your school. And you do cat schoolnames.txt. Then what that would normally do is just output that list of names. But let's say you want to sort the names in alphabetical order, because a lot of times it's useful with like school names. Then you can do cat filename.1, and instead of printing it out to the output, it'll pipe all those names into sort, and it'll sort them alphabetically and then output that. So instead of having to go through multiple steps, you can just do that all in one command. And now we're going to talk about regular expressions, or what some people call them like regex expressions. So regular expressions are not just for Unix. They're used in almost every single programming language out there has uses for regular expressions in some way or another, whether it's like trying to like deal with strings or whether it's trying to deal with strings or it's trying to deal with strings or it's trying to deal with like different texts or different like delimiters. There's always a use for regular expressions in almost every language. But what they're basically used to do is describe text in patterns or filters. And they're used heavily by many Unix commands as well. And some of the basic ones are the brackets. So the brackets matches any of the enclosed characters. So brackets A, B, C searches for text that has an A in it, a B in it, or a C in it. Or let's say you have bracket A to Z. The A-Z, what it does is it matches any text that has the alphabet A, B, C, D, Z. Any one that has any character of the alphabet, it'll match that. So pretty much everything. And then you could do, and then some really like some more complicated stuff you can do with this. Let's say you do bracket lowercase k, uppercase k. Let me mouse over it. Bracket lowercase k, uppercase k, and then ORN. So what that'll do is it can search for lowercase k, ORN, so corn, or uppercase k, ORN, so corn with a capital K. And a lot of these things in Unix, and this is just like a fair warning for like later, a lot of things in Unix are case sensitive. Like if you mess up the capitals, it's not going to be like, oh, you can just it'll still work regardless. Like you need to make sure that a lot of your commands, a lot of things you're running are the exact casing you want them to be. Otherwise, they might not work, or they might not work as you intend them to be. Let's say, go back. So let's say this example where you do brackets B. This might look kind of like gibberish, but let's say you do brackets B, bracket EOR, bracket A, bracket T. So this might not look like anything, but what it does is if you want to break it down, it'll search for anything that first has a B, the next has either an E or O or an R, and then next an A, and next an T. So no matter what, the thing will have to start with a B and end with an AT, but the second character can either be an E, O, or R. So what that lets you do is it lets you search for beat, brat, or boat, all in one regular expression. Instead of having to search through, is beat in here, is brat in here, is boat in here. It lets you search for all that in one regular expression. And then if you want to search for any character, you can use a dot. So let's say you do bracket O, bracket dot, and then just plain bracket. What that lets you do is it lets you search for O, R, like O, and then any character after. So O and then anything, and then a blank space. So basically words that end in O and then something else, it'll search for those. But 2 does not fit with that because there's nothing after it. There's a white space after it. It needs to be a character, not a white space. Some more options and examples with regular expressions are like dot matches any single character, star matches 0 or more of the immediately preceding expression. So if you do ABC star, it'll do any number of A, B, or C. So you can do A or ABC, BC, or AC, BC, A instead of just doing 1A, 1B, 1C. The question mark matches 0 or 1 instances of the immediately preceding expression, which sounds kind of complicated, but basically if you have X, then ABC question mark X. You can do XAX or XX or XBX or XCX. Plus matches 1 or more instances. The caret matches a preceding expression at the beginning of the line. So if you do caret dog, it'll match lines starting with dogs. Or if you do caret dog, if you add a $sign, it'll match lines starting and ending. So $, for ending, caret is for starting. And if you realize like a lot of these are not like self-explanatory. Like if you looked at like a question mark or a plus or a caret, you wouldn't know that it does what it does unless you try it out a lot, unless you play around with it. So a lot of this stuff is like you can't just like memorize it and hope to like use it like that. You have to actually play around with it and know like which one of these you're going to use the most, which one of these you don't use as often, and what works best for you when you're actually trying to use these regular expressions in actual code or in Unix environments. And then backslash turns off the special meanings if you want to escape certain characters. So some interesting ones you can do with this is, let's say, match length. So a match will be the longest string that satisfies a regular expression. So what you can do here is a dot star e. So what this will do is, if you go back, so the dot matches any single character, and the star matches 0 or more of the immediately preceding expression. So what this does is it'll do a dot and then star and then e. So what this will do is it'll match the longest string that starts with an A and has anything after it until an E. So it'll match apple, then it'll match a, like apple from the, because this technically, this whole thing for this whole red arrow is also another string, a, e. Or it can match apple from the apple, because that also starts with an A and ends with an E. So it'll match any string that satisfies a regular expression, but it'll be the longest one, because that's how regex works. So instead of being apple or apple from the, it'll be apple from the apple. That's what it'll return. Or you can search for repetition. So you can do A, P, star, LE. So look for an A, then I'll look for, because there's a star after it, any number of P's, and then LE. So it'll get apple, and it'll also get apple as well, because it's any number of P's. Then it's A, any number of P's, then L, then E. And yeah, like, I'm not going to go over all of this, but there's a lot of stuff you can do with regex. Like, I haven't even like scratched the surface of what you can do with this, and it's really, really, really powerful in the things you can do and the ways you can search like different texts and honestly like find almost anything you want and search for files for anything that you want in really, really powerful ways. The next command we're going to be going over is a command that tells you about other commands. So this is called the man command, which stands for manual. And the man command allows you to access the manual pages for a Unix command. And it's basically the first and maybe honestly the only command that you need to know in order to do all of Linux. So any command that you don't know what it does, like any command at all within Unix, you can just type man in the name of that command, and it'll tell you everything about that command, like how it works, what it does, what the different modifiers do, everything about it, and everything you need to know to use that command. And there's man itself, like the man has its own manual page. You can do man -k and look at a command to see like multiple manuals for it. Let's say you want to look at the manual for the password command. You can do man password, and they'll give you the manual for the password command. But some of them have multiple pages. You can do man 5 password and get the 5th page of it. So any command that you don't know at all within Unix, you can just do man and find out what it does and find out everything about it. It's really, really convenient to know, because it's really hard to memorize all these commands, especially when you don't use all of them on a day-to-day basis. Okay, so another command that's like really simple but also used really, really, really often in Unix is what's called echo. And echo is basically it just echoes back or prints out anything that you type into it. So let's you say echo how are you, it'll just print out how are you. It's basically like the print command. If you guys know Python, or like system.out.println, if you guys know Java, it's just whatever. So echo how are you, it'll say how are you. If you type in a variable b = 50 and you echo $b, so what so if you did echo b, it wouldn't echo 50, it would just echo b into the command prompt. But if you do echo $b, it says, oh, what's the value of the variable b? So just print out 50. Or you can do echo star, and it'll just list all the files in your directory. It'll just echo everything in your directory, kind of like what ls does. So there's next couple commands is what's called head and tail. So head and tail are used to show the first like so many lines from the top or the bottom of the output. So head is used for the top. So if you do head of a file name, it'll show you the first 10 lines of a file. So if you have like a text file with like 1,000 lines and you just want to see the first couple, just to see what because you forgot what the text file had in it, you could do head, the file name, and show you the first 10 lines of that 1,000-line file. You can also specify it. You can do head -20 and get the first 20 lines, or head -n20 if you want to do it that way. And these commands will both show you the first 20 lines in that file. Or another like useful way to do it is, let's say you have let's say your documents folder. Let's say it has like hundreds and hundreds and hundreds of files, but you want to see the first 10 files in that directory. You can do ls-l star, which basically just lists all of the files in your directory and a lot of information about them, and then do head just to get the first 10 files. And then tails, exactly the same thing except the opposite. It's just, instead of showing how many lines to the top of the file, it shows how many lines to the bottom. So you can do tail 20 and get the last 20 lines. Tail n20 is the same thing. ls-l with tail, or tail -100f. So -f is actually like a really, really important thing because it lets you show the contents of the file in real time. So let's say you have a file called server.log. And what that does is every time someone accesses your website or accesses your server, it'll print out their name and what they're accessing. So what you can do is, if you do tail -100f server.log, it'll print out in real time the last 100 lines from that folder. So as they keep making changes, it'll keep updating the -100f and keep showing you the last 100 lines, and just let the others roll off on the server.log. So if you want to have like a real time, like sort of log or real time like error thing for your application, and you want to see like what's going on, what's like the recent updates that's coming, you can use -f and get a real time version of it. Okay, so the next commands that you can use is more, less, or page, which is PG. And that shows the contents of a file screen by screen. So some files are like thousands and thousands and thousands of lines long. And if you've ever done work in the command prompt, or you know what the command prompt looks like, you know that if you try showing the contents of that file, it'll just blow up your entire screen, and like it'll just keep scrolling and scrolling and scrolling and scrolling, and it's really inconvenient, and oftentimes you're not able to scroll all the way up to the top to see the top of the file. And so instead of trying to like scroll and scroll and scroll and scroll and scroll through like a really, really long file, what you can do is you can use more, less, or page to show the contents of the file screen by screen. So if you do more and a file name, it'll show the contents of the file, and it'll let you like actually navigate that file like page by page by page by page, instead of doing it like all at once. Or you can do ls and then pipe that into more, and ls type pipe that into the page. And that's the same thing. Like I said before, let's say you have your documents folder and it has 1,000 files in it. You can't just do ls, otherwise it'll blow up like 1,000 files. But if you want to navigate your folders page by page by page, you can do ls and then pipe that into more. So you can navigate all your files like page by page, just like find the thing you're looking for, or see how many files you have in it. And PG does the same thing, but with less functionality. So more and PG are sort of historical utilities, but less is a more modern version of it with some more capabilities. And when you do more, you can press space to view the next screen, enter to go line by line, B to go up one screen, / search for a string, and Q to quit. And a lot of these things, like it's like they don't like tell you the keybinds for it. But if you do the man, like I said before, if you do man more, man less, man PG, you can look at the menu and learn how to use these commands as well. And then there's like different like modifiers you can do for it. Like more lets you do more, less, and page all have -C, which lets you clear the display before displaying the contents of the command. So instead of like having some of your commands show up here and then the page showing up there, it'll let you take up the entire page at a time instead of having anything else there. Less has what's called -L, dash dash I, which lets you ignore case. More as dash W, which doesn't exit at the end of the input but prompts and wait, but less than page has that by default. And then more and page have dash lines, which lets you specify how many lines you want per page. Like if you only want like 1,000 lines per page, or if you want like 10 or 5 lines per page. Okay, so like if you remember back to the beginning where I was talking about like awk and sort, what the sort command does is pretty self-explanatory. It sorts the contents of a given file using the ASCII format, which is like the general string and text format that almost all programming languages use. And it sorts the contents of a text file line by line. And another thing to make sure is that it doesn't change your original data. Like it doesn't, like if you have a file with a bunch of names in it, you do sort that file. It doesn't change the actual file itself. It just sorts it in the output. Yeah, so basically it sorts the contents of a file using ASCII format, and there's a couple of like modifiers you can do to it as well. But the basic field separator, like the basic thing that separates columns or like new lines, is a blank space. So you could do sort input file, and that'll just sort the file, or you could do sort input file and then pipe that into an output file. So if you don't just want it outputted, you want to actually write what that sorted is into a new file. You can actually pipe that, like you can redirect that input into an output file, because like I said before, it doesn't change the original data; it just outputs it. So if you actually want a file that has that sorted data, you have to use a redirection operator and put that into an output file. And some of the options you have, you can sort in reverse order, numeric order, by month. If you have date formats, you can ignore cases. The unique command is also like kind of self-explanatory, where the unique command reports or filters out repeated lines. It basically gets the unique lines in a file, but with a bunch of options you can add as well. So it helps detect adjacent duplicate lines. It deletes duplicate lines, but the thing is, it's not able to detect duplicate lines unless they're adjacent, which is an important like contingency you have to know. So if you want to use unique and you want to get the most out of it, you should probably sort the file before you use unique, because then all the duplicates are going to be right next to each other, so you don't have to worry about that. Or you can use sort-u, because sort-u gets the unique operators anyway. So you could just sort-u and then just pipe that into an output file if you don't want to deal with having to sort it beforehand. But the general syntax is unique. Whatever sort of input thing, whatever sort of modifiers you want to add, and then an input file or an input file, and then into an output file if you want. So you can do unique input file and it'll get by default to only print the unique lines in that file. Unique -c, which counts how many times each line is found. -d, which only prints the duplicate lines. So instead of printing the unique lines, it'll only print the ones that are repeated. -u, which is like the default, and -i, which is ignore case. Because like I said before, by default, Unix is pretty case sensitive. The next thing is like alias. So alias and unalias, what they let you do is, a lot of times in like when working with Unix, you'll realize that you run the same command over and over and over again. And a lot of times that can become pretty tedious, like running the same command over and over again, or you don't know what a command does, but you keep having to look for that command, you keep having to type it out. So instead of typing a command out over and over again, what you can do is you can make an alias for it. So let's say you run rm-r often, which is like a remove file command, and you run that a lot, but you always use -r when you're doing rm. So instead of having to type in rm-r every single time, you can alias rm as rm-r. So every single time you type in rm, it'll run rm-r. And the same thing you can do with ls-l. So let's say, every time I run ls, I always do -l. So why don't I just alias ls-l, and then so I don't have to type -l every single time. It'll automatically type that out whenever I use ls. Oh, hold on 1 second. Make sure or something. Okay. If you're moving from Windows to Unix, then another thing is like if you're used to like using dir or copy or del instead of using ls-l, cp-l, or rm-l, then you can use aliases for that. Like the aliases can be whatever name you want them to be. They don't have to be like normal Unix commands. You can write whatever one you want. Like if you alias remove specific folder and you do that rm minus rf, then that could also be an alias for you want. You can name the alias whatever you want. So you can name it dir, copy, del. But with no arguments, it'll list all the current actively aliases. And if you want to remove one, you can do unalias in the name with alias, and it'll remove it for you. So find, what find does is it'll search for files in a named directory and in all of its subdirectories. So it's basically for finding files. Kind of like searching files like you do in a file explorer and Finder if you have a Mac. So if you want to find by file types, so the basic syntax of it is find the directory, the type, any like sort of commands you want to add, name, and then pattern if you want to do that. So a basic example is find dot dash type f dash name star dot text. So what this will do is it'll find everything in your current directory. So dot means your current directory, with the type is a file, so type either is F, D, or L. D is a directory, so like a folder. F is a file, and L is a link. So you want to see find everything in my current directory. That's what this. Hold on, let me see. Okay, hold on. So find this dot means everything in my current directory that is a file and that ends with text. So it's a text file. So find every text file in my current directory. Or what you can do is find everything in my current directory that has a size less than 1 kilobyte. So the minus means less than and the plus means greater than, by the way. So you could do find everything in my current directory that has a size less than 1,000 bytes, or find everything that has a size greater than 100 megabytes, or find everything that has a size greater than 100 megabytes, but also has a size less than 500 megabytes. So stuff between 100 and 500 megabytes. So you can actually like narrow down the files in your directory pretty easily. And there's a lot more stuff you can do with it. Like, there's going to be a few slides of this. So you can find files by the modification time. So M time was to do that. So find files that are modified 1 day old, that are less than 1 day old. Find files that are more than 2 days old but less than 3 days old, so in between that time frame. Find files that are less than 15 minutes. Find files not accessed in the last 30 days, so A time is access time. Find files that are newer. So newer MT lets you say like newer than the time that June 2, 2021. So this is date format. Find, and you can use this also as well as like find files that were made between, let's say, January 1st and June 1st. So if you want to find files that are between January 1st and June 1st, you can run this command. You can find all files, and it doesn't have to be your current directory as well. You can do find files in the /home directory that are newer than this file. So let's say you want to compare files. Like you have a file that you know the date that it was made, but you want to find files newer than that. So find all files in the /home directory that are newer than the one file in the home directory. Or you can put this exclamation mark, do not. So find files in the home directory that are not newer than the one file, so older. And finally, like some more stuff you can do. There's even more beyond this as well. Like this is a lot of like the use cases that I could think of and that people like usually use the find command for. So you could find by permission. So you can find files in your current directory that have certain permissions. Like guys might not know what this is right now, but RWX means like read, write, and execute. So certain users, certain groups might not have permission to write or read on a file, which means edit or read from a file. They might not have permission to execute it. So you can search by permissions. You can search by like Java files. You can there's a lot of like different crazy syntax you can do with this, and a lot of different powerful things you can do. Okay, 1 second. All right. So the WC command, I'm going to speed up a little bit because I just want to make sure we get through everything on time. WC command shows you word counts. So it counts lines, words, and characters. So you can do WC with -C, which will count the number of bytes, -N, number of characters, -L, lines, and -W, words. Words are limited by white space or new lines. So that's how words are counted. Let's say you have like a PDB file, and let's say you do WC *-PDB. So look through every single PDB file in your directory and say, all right, how many words, how many lines, words, and characters are in it? There's 20 lines, 56 words, and 158 characters. And that's how the order is. We can do WC-L and just get lines, or just get characters, or just get bytes. There's the cut command, which is used to cut out sections from each line of the files and write the results to standard output. So basically it like cuts the file vertically. So you can say that it slices the line and extracts the data. So you can cut parts of the line by the byte position, the character, or the field, which is kind of like a column. So the syntax is cut option and then the file. So the options are like C for only these characters, output only these fields, use this character as a field delimiter, or turn off the special meaning. So you can output only the characters that match it, output only the columns that match it, use a different delimiter. So instead of doing like spaces or new lines, you can use colons or commas, or you can escape a character. So you can cut -B, which will extract the first, second, and third byte. You can do 1-3 to 5-7, so 1 to the first to third and the 5th to 7th byte. Everything from the first byte to the end. You can do for columns, you can do it for fields, and you can change the delimiter to use space instead of new lines. So the next command is TR, which is translating. It's not like, it's not like a Google Translate. It's like a translate in terms of string, like string translating. So what this lets you do is it reads the input from standard input and it writes it to standard output. It doesn't use files. So basically, it translates one set of character sets to another one of the character sets. So if you want to convert uppercase, lowercase to uppercase, so you say, so you have a file called Greek file, and you want to translate it from uppercase to lowercase to uppercase. So you can do cat Greek file and then pipe that standard input into TR and say, okay, everything lowercase from A to Z, I want to make it capital from A to Z. Or you can do dash lower dash, colon lower colon, and colon upper colon. That's like a special way to do it. You can translate white spaces to tabs. You can remove digits from a string. So they have digits commands. They have delete specified characters. So you can delete the W and ignore case. So you can do TR-GW, and I'll now say welcome to geeks instead of welcome to geeks. You can do a lot of different things with like remove all the characters except digits. So you can echo my ID is 73535, and then TR -CD. So delete D lets you delete everything but the digits, and then it'll only get 73535, and you can do more with that after. So another like important command, and a really important command actually in Unix, is what's called Grep. So Grep stands for Global Regular Expression Print, and allows you to search for text within files. So search all the files or specific files for specific text. And it's kind of like other text manipulation commands like cut, tr, awk, and set. And there's different ones in the Grep family, and you can use a manual to find out more information. But some of the basic options they have for it is -V for input inverse output, so print lines that don't match the pattern instead of printing ones that match. Print only a certain amount of count matches, print line numbers, print don't print file names, multiple searches, and ignoring uppercase and lowercase. The general thing, this is grep, whatever options, whatever pattern, and then file name. So grep something in a file. So grep pattern file name, grep pattern file 1, file 2, grep -I for ignoring uppercase in student.txt, grep -vi for my name in student.txt, which will print everything but my name in student.txt. You can pipe into grep, and if the pattern is found, the grep returns it exists out of 0, but this is more complicated stuff you can do. But basically, it also returns statuses based on like what the grep returns. So if it finds the pattern, then it returns a status of 0. If it doesn't find it, it returns a status of 1. And if the file itself is not found, like it's not even like the pattern doesn't work, the file is not found, then it returns a status of 2. So there's even more examples of stuff you can do with grep, like grep-l, which will list the name of all text files whose contents mention new. So you can do grep-l star.txt. So look for every text file in your directory and grep every single one of them that has new in it. Or you can search for the word like Mehar, grep-r Mehar. Search for all the word Mehar in all the files under the home mjhal directory. You can grep for specific words like do instead of does or done. You can list the line numbers which contain the word johal. You can search for multiple words, display surrounding lines, display one line after the line. These two are important. So grep-r-a1. So what this does is it'll search for johal. So search for the word johal, and it'll do, if you have -a1, it'll display one line after the line that contains the word johal. So -a means after, and 1 means one line. So it'll show the line that has johal in it, but also show one line after. Instead of, if you change it to A to a B, it displays one line before. Or you can do -b2 for 2 lines before, or -a2 for 2 lines after. And you can also pipe into grep as well. So you can list all the files in your directory and then grep for a specific thing. You can cat a file or cat a directory and then grep for like a model from it. And there's also fgrep, which supports only string patterns, no regex expressions. There's grep, and there's egrep, which supports a lot more regex expressions. So there's different grep commands you can do based on the use cases that you need. If you want fast ones and you don't care about regex, you can do fgrep. If you want the normal one, you can use grep. If you want more regex expressions and more like flexibility, you can use egrep. So the next, and one of the next like really, really big commands, like we said before, there's awk, there's sed. Like there is awk, there's also sed. And what sed does is it's basically another one of those like text editing commands. So this text editing command, what it does is it's called stream editor, or sed for short. And it's an editor for modifying large files and large data sets. And it applies a rule based on a stream of data per line. And I'll explain what that means in a little bit. And it applies that rule once per line unless you use like a global argument. And it's useful, basically the thing that it's used for like almost always is for really complex find and replace things. So let's say you echo hello. And so that usually would print hello into the command line. But you pipe that into sed s/hello/hi. So the way that sed works, and you'll see in all these things, is you do s/ and then the thing that you're looking for, and then another slash and what you're replacing that with. So you find hello and replace it with hi. That's how the syntax works. S/ what you're looking for / what you're replacing it with. So in this case, it'd be echo hello, and then sed look for hello and replace it with hi. So then it'll print out hi. Or hello Mehar hello. Look for hello, replace it for hi. And it'll do hi Mehar hello. But look, it only does it once. Or you could do echo hello mayar hello, and then replace hello hi, but do it globally. So do it every single time and not just once. So replace all the hellos with highs. Or you could do replace only the second hello with hi. We'll do hello mayar hi. So you can really like you can really like as you can see, there's like really intricate things you can do with it on top of just the basic like find and replace. You can do stuff like delete files that have the word hello. So you can search for like, okay, hello, and then delete lines in that file in file one that have that line hello. You can delete lines starting with a number or with like the pound sign. This like escapes the pound sign. You can delete the first two lines in the file. And this is sort of like some of the stuff you can do. So like D deletes all the lines. 6D deletes line 6, and as you can see, it just gets more and more and more and more and more complicated and more like a really intricate find, replace, and deletes you can do with this. Some more things you can do with SED is so S/ you can do this and replace all of the leading white space. So this regex expression gets all the leading white space and replace it with blanks. So you can trim it off. You can trim trailing white space, which also, as you see, is another regex expression. You can trim leading and trailing white space with this regex expression. As you can see, like /t gets space and then star for as much repeated. So like you can do really complicated stuff using regex expressions in combination with SED. And then you can use this to change quote slashes from / home to /new home. So you can escape the slash using the backslash and change /home to /new home, or use colons or use pipes instead. And there's even more stuff you can do. So you can like specify lines you want to translate on. You can specify like lines you don't want to translate on. Use multiple ranges, change multiple like hellos. You can this one's been pretty important. So you can put all the commands into one file, and then you can basically make a script out of SAD scripts and put that into one file, and then actually use -f and put all the scripts in one file and actually call all those scripts at once if you have a lot of them you want them on. And there's just this is even more stuff you can do with it. So the final thing we're going to talk about is awk. So awk is called awk because it's created by 3 people named Aho, Weinberger, and Kernighan, and they're the people who created the awk like sort of infrastructure. And so awk is basically an extremely versatile, like full-fledged programming language for working on files. It's not even like a command. It's like basically its own entire programming language just for working on files and changing stuff within files. And I can't really teach it within like the amount of time that we have, but I'm just going to basically introduce it to you and show some basic ways on how it can work. And it can process awk can process like fields and columns, while SED can only process lines. And basically what awk does is it scans the file line by line. It splits each one of those lines into fields, which are like basically columns, and it does all of its comparisons and performs its actions. And it can get input from files, pipes, or directly from standard inputs. You can do basically a lot more things than SED can do. It's useful for transforming data files, producing formatting reports, and there's different versions of it as well, like Grep. There's awk, which is the old original from AT&T, knock, which is newer from AT&T, and then gawk, which is an open source version of it. So the basic structure of an awk program, and this is going to seem kind of complicated, but it's something you have to sort of explore more on your own. But basic structure is a begin, an optional begin section, a pattern, like what you actually want to run, and then an optional end segment. So a begin segment is an action performed before the first input line is read. Like let's say you want to sort it or something, and then an end action is stuff like, I don't know if you want to like pipe the output into somewhere else. So there's several ways to run awk programs as well. Since it's like a full-fledged programming language, you can awk and then actually run the program in one line. You can awk just the program, or you can actually type the program out in a file and then do awk-f to run it like that. So simple output from awk. If you do curly brackets and print, it'll print everything that you inputted into the output. Or if you do print $0, it'll do that same thing. But if you want to print certain fields or certain columns, you can use $1, $3, whatever field you want to print out, then it'll print that. And expressions are separated by a comma by default, and they're separated by space in the output. So let me see. Okay, so let's say you have this this server.log file here. It has a bunch of different things in it. It looks kind of complicated, but let's say you just want to get the number of fields or number of columns in it. Then you could do awk print nr and nf-2 server.log, which will get you the number of records and the number of fields, and then the second to last one for each one of these. So basically what this does is this looks at all this, and since it's split by fields, this is one field, this is one field, this is one field, this is one field, and then this is one field. So what it does is it goes 2 fields back from the end, so 1, 2 fields back from the end, and then prints that field for all of them. So as you can see, it's 200, 200, 200, because if you move 2 fields back, then that's what it gets. Then if you have like Mehar Johal grade 12, and you awk print 0, it'll print everything. But let's say you just want the first line. Since awk splits each one of these into fields, you can do, if you just want Mehar, you can do awk print $1, print just the first field. Or you can do print $1 and then add is student of and then $4. So basically what this does is it gets, okay, so the first field, Mehar. Mehar is student of class, and then, okay, add the fourth field. So 1, 2, 3, 4, 12. So Mehar is student of class 12. And that's some of the basic things you can do with awk. And you can change the field operator. So instead of doing like spaces, you can change the separator to new lines or tabs or colons or commas, whatever you want or whatever you need based on your input file. Let's say this is some more examples. Let's say you can awk print number like $2 and get the second field like we did before. You can print the date. You can actually pipe awk commands into other awk commands. So let's say you print $2, which gets the second field, and you just want to print the first field within that. So there, you change the delimiter to colon. So you change the delimiter to colon and say, okay, so now I have this bracket segment. Now I want to split on colon and see what the first thing is there. That's the date. So then that returns bracket 26 April 2000. It's like, oh, I don't want that third bracket. So you can pipe another into SED and translate that bracket into a blank space. You get 26 April 2000. And these are just some more examples you can do with it. And then this is just some of the more like sort of basic operators you can use with awk as well. And as you can see, like there's a lot of stuff you can do with awk. And this is like I'm going to be sharing these slides with you. So if we didn't get to cover this because of time, but as you can see, there's a lot of different things you can do with awk. And this is barely even scratching the surface because you can do entire programs for awk running on like big, large files and actual commercial databases. So that's the end of this presentation. The next presentation is going to be one on IoT, so you guys can start heading over to there. And we'll be starting in a few minutes from that. And as always, like these slides and these recordings are going to be shared with you guys after this presentation is over. So I'm going to end this webinar now. You guys can start heading over to the second one on the IoT.